Linear approximations. So now that we've learned how to take partial derivatives, let's see how we can use partial derivatives to accomplish something. Let's start with the notion of a function between Rn and Rm. So by definition, a function f from Rn to Rm is a rule that we refer to symbolically as f colon Rn right arrow Rm. And what a function does is it associates every vector x in Rn to another vector f of x in Rm. Now, in this situation, we call Rn the domain of the function, and we call Rm the target of the function. So we can plug vectors from Rn, the domain, into the function, and the function will take that input from the domain and associate it to a vector in the target. Now, if you think about what this function would look like if you looked inside the nuts and bolts, it would look something like this. This function would accept n scalar inputs, x1 through xn, and then it would take each scalar input and it would construct a new vector with m coordinates. Perhaps the first coordinate is called f sub 1 of those inputs. So let's call that f sub 1. And if you think about what this is some scalar field. This associates a vector in Rn to some scalar. The second coordinate, maybe we can label that as f sub 2. This would be another scalar field. And then we keep going until we get to the mth coordinate, which we would label maybe as f sub m. So the idea is that all of the coordinates of the output of this function are themselves scalar fields. And I like to call these scalar fields the coordinate functions of the function bold f. So here's an example. Here I'm looking at a function from R3 to R2. That means that this function accepts 3 inputs and has 2 outputs. So the inputs into this function I'm calling x, y, and z. And so what are our 2 outputs here? Well, my first coordinate function is x times y. So I'm going to call that f sub 1. My second output here is negative yz cubed plus x. I'm going to call that f sub 2. So this function from R3 to R2 associates any 3 inputs to 2 outputs, and those 2 outputs are labeled as the coordinate functions as f sub 1 and f sub 2. Here's another example. This is a function g from R4 to R3. So this function accepts 4 inputs and has 3 outputs. I'm labeling the inputs here as p, q, r, and s. And this function will take those 4 inputs and associates it to the 3 outputs, where the first output is pq plus r. I'm going to call that g sub 1. The second output is p minus s. I'm going to call that g sub 2. And the third output is e to the p times s squared. I'm going to call that g sub 3. So this function accepts 4 inputs, and then it will take those 4 inputs and produce 3 outputs, which I'm labeling as g sub 1, g sub 2, and g sub 3. Here's a third example. This is a function h from R to R3. That means that this function accepts 1 input, and with that 1 input, we construct 3 scalar outputs. The first scalar output here is cosine of the input, which I'm calling t. So that will be labeled as h sub 1 here. The second output is sine of the input, so sine of t, which I'm labeling as h sub 2. And the third output is just t, that's just whatever the input was, and I'm going to call that h sub 3. So anytime you construct a rule that goes from Rn to Rm, you can look at the individual coordinate outputs, and each one of those outputs is itself a scalar field.